Hello everyone. This is Rashid Kibria from Fixed Research University of Florida. Today I will talk about a very brief uh, talk on the RTL-FSMx tool. This tool, I always believe that tool is something like a product. So our paper on RTL-FSMx was accepted recently at International Test Conference 2022. On this presentation, I will provide you the key ideas or key features of RTL-FSMx and what makes RTL-FSMx unique from the existing solutions. I will first focus on the overview or the high-level architecture of RTL-FSMx. I will skip the technical details because you can watch them in my other presentation in my conference demo. We take here input RTL designs written in Verilog HDL as input. And RTL-FSMx basically uses PyVerilog to generate the abstract syntax tree of the RTL code. This abstract syntax tree acts like an intermediate code to be analyzed because it is always easier to analyze the abstract syntax tree representation of any source code. On that, the main or core part of RTL-FSMx, which is the FSM recognizer and stage extractor works and provide you all the reports like state variable, vector, encoding, state transition graph, and the input and output signals of the control FSM. There is one dependency of RTL-FSMx, a third-party tool dependency, that is Icarus Verilog. You must have this in your system to run RTL-FSMx because PyVerilog actually uses Icarus Verilog in the backend, and PyVerilog is basically the only open source Verilog HDL compiler which provides support for like 99% of the Verilog HDL constructs. That is why it is so much popular in our academic community, and we basically use this compiler extensively for developing our academic solutions. Here is shown some of the key features of RTL-FSMx. RTL-FSMx basically uses black box approach to recognize all the control FSMs present in the RTL. It automatically identifies important information of the all detected FSMs. That means RTL-FSMx can identify the clock and reset signals of the FSM, the reset state, state encoding, S3G, and FSM inputs and outputs. RTL-FSMx also visualize each detected state transition graph in both text and graph representation. So it basically makes the post-processing very simpler for you to analyze the state transition graph to perform any sort of verification or other security-related tasks. One important thing I want to mention is that RTL-FSMx can extract FSMs even though multiple FSMs are present in a module. You will not see this feature in existing solutions. I have seen even some industry grade tools actually detected only one FSM inside a module, but actually skipped the others. It is a bad thing in terms of security because you cannot detect the second FSM there. What happens if the second FSM is very important in terms of security? Now that is the problem or an issue, and RTL-FSMx is a very good solution or candidate for that application. Another thing I want to focus is that RTL-FSMx can analyze complex expressions which cause state transitions. It was a very hard task. But my tool RTL-FSMx can do that, and really it took a lot of time. The development time on this task because developing this application was not that easy. It was a complex project basically. RTL-FSMx is also able to analyze RTLs having both one process and two process FSM models. It can also handle all possible state encoding techniques. That means sometimes you can encode your states using numbers, or sometimes you can use symbols. Both of them are permitted from RTL-FSMx viewpoint. Designs with multiple domain clock signals can be also analyzed. And also RTL-FSMx can analyze design having nested FSMs. That means sometimes you may have one FSM inside just one state of a big FSM. So RTL-FSMs can identify both of these two FSMs individually. It actually provides you the FSM it has something inside like FSM decomposition technique, which actually decomposes these two FSM and show you the two FSMs there. Because that is what, right? One FSM inside a very big FSM. That is also analyzable using RTL-FSMs. Another thing, RTL-FSMs can also analyze FSMs having if-else constructs. This feature is also absent in state-of-the-art solutions. There is a version of RTL-FSMx which can do that. It is very similar to the V1 version. And also, FSMs with both synchronous and asynchronous resets can be handled. In this slide, I have basically shown you a sample report from one complex FSM. This FSM is coming from OpenMSP 430 CPU. This is basically the second FSM of the OMSP underscore frontend module. Why I call this a complex FSM? Because you can just look into the state transition graph. It has so many states, so many state transitions. This FSM was not detected by Quartus Prime. Quartus Prime has a feature called FSM Viewer, where you can view this sort of bubble diagram of a control FSM, but this FSM was actually skipped by Quartus Prime. But RTL-FSMx is able to handle that, and so it is actually providing you this very beautiful STG along with their state transition graph in text format as well. This design is also extremely complex. If you look into the RTL, I will just get that idea. So I will not talk about that more. Yeah, these are the features what actually makes RTL-FSMx unique in terms of application. Hope you enjoyed my presentation. Thank you.